All right, we are back again, and this time this tutorial is all about EES, that is Engineering Equation Solver. Now, you all may have seen that not everyone or like not many videos are available on this platform on YouTube about this particular software. Well, that's because this software is quite specific and it's mostly used by engineers, and not many engineers are using this platform to share information. So yeah, that's one thing to clear about. Why is it not that famous? And there's another thing which I wanted to tell you. I uploaded a video how to download it, but then YouTube took it down. So yeah, if you really want to get it, and like you know what I'm saying, so yeah, you can always like comment it down, and maybe like I'll figure it out how can I share it with you without letting them know, right? So yeah, let's get along with this tutorial. So in this tutorial, what we are going to discuss is, suppose you are a complete beginner, you got this software somehow, and now you want to know that like what should I do with it, right? There are plenty of options in here, and there are a number of maybe buttons you can say that are here. So what exactly do we do in engineering equation solver? Well, like a one line answer would be we solve engineering equations. That's kind of quite obvious by the name, right? And a more specified answer can be that there can be a number of things, number of variables which we can't really control. Like suppose in case of thermodynamics, if we want to calculate enthalpy or entropy, we actually need to know a number of variables in to like put it in a formula, right? But with engineering equation solver, what you need to do is you need to just import a formula and that's it, right? So this is how and why it's widely used, right? So let's start. Sorry for that. Okay. So the first thing after you open it, you should go to options and unit system. So why is this step important? Because sometimes, well, it should not happen, but if it does, then you want to see that the unit system is obviously SI, right? The specific property should be mass, kg, right? And then temperature is in Celsius, Kelvin. You can change it whatever you want. You can like keep it in Kelvin, right? Pressure units can be kilopascal, pascal, bar, megapascal, anything that you want, right? Then energy units can also be changed, kilojoule or anything. Now, let me remind you that all these units are really important because sometimes some variables might not have a unit here, right? And you need to know like what is the unit of this variable. So these are the units that are used by default, right? And trigonometric functions will be measured in degrees. You can change it obviously to radians or whatever you want, right? So that's one thing. I'm going to keep it whatever it is as the default. Click OK, right? It's going to save by itself. Now again, go to options. Now there are a number of things that are here, right? One is variable information, the other one is function information. Now, variable information is something which you will be using after you declare or after you write a code about something, but function information can be used by you at any point, right? So there are a number of functions. These are all the libraries in this software, particular software, right? There are thermophysical properties, there are mechanical design property, heat transfer, everything, right? So yeah, and there are fluids as well. These are the NASA approved fluids, right? They are. Now, if you are working in NASA, well, I'm not, then I can't really verify it's that way. But definitely, they are all approved by the NASA. That's why they are here. Then there are incompressible fluids, which I don't, yeah, There you go. These are the incompressible ones. These are the ideal gases. They're all basically sorted, right? Then what are these are brines, right? So we are going to work with real fluids for this particular tutorial or example, let's say, right? These then there are these EES libraries, right? All right. External routines. These are the external functions, external kind of what you can say predefined functions which you can use if you want, right? So we'll stick with thermophysical properties, right? And here you can see a number of like what you can say familiar thermodynamic properties, right? So enthalpy we can see entropy here, right? All these kind of things we can see, and here are the fluids. Now, if you really want to know about fluids and what they are, then you can obviously search it on Google, right? What fluid is organic, which one's not, right? Like R123 is organic, right? R41 is organic, so and acetone as well, benzene as well. So there are number of things which you can search about, right? So what we are going to do for this particular example, let's say I want to calculate the enthalpy of the fluid, like let me say like methane, whatever you want, you can like choose anything, right? For this particular example, I'm choosing methane. You can actually like go along with anything that you want to experiment, right? It's kind of our own personal lab, right? So now in order to calculate enthalpy, there are a lot of variables that you need, right? But with EES, you can actually choose two of the variables that you have available with, right? So suppose I have the temperature reading of methane at a particular point, right? And I have like let's say pressure reading of methane at a particular point. So this is the formula, right? Now you one thing you can do, you can just copy, select it, Control C, Control V here. Another thing, you can just directly paste it. So wherever the cursor was, it's gonna paste this formula as it is, right? You can obviously type it as well, but that's kind of time consuming. I find it like that. Right now, here you can see T equals T, P equals P. These are the variables. H is it's like denoting enthalpy, right? Methane is a working fluid, right? T is temperature, P is pressure. Now let me just tell you what it is like, right? So enthalpy is basically a property, right? Property. So this is the basic what you can say syntax, right? Then there comes fluid, right? Okay, the keyboard is quite messed up right now. Wow. Now this now like P is one of the properties or one of the variables that we actually know that we have like we know about it, we have the value of this variable, right? So we are going to name it variable 1, right? Then Control C, Control V, and this is variable 2, comma, and boom. So this is the basic syntax, right? Now I can denote enthalpy by anything I want. I can do it P, right? But since we don't pressure, so it's kind of confusing. That it's denoted by default, right? So you actually have the basic idea now, like what is this formula and all that, right? Now this T equals T and P equals P, it's like this variable which is on the left side is in the syntax, right? And this T is what you have to define, right? So if I define T1 equals 40. Now let me remind you temperature was in Celsius. So here as well it's in Celsius only. So 40 degrees Celsius, you don't really need to add a C or anything like that here, right? And P1 equals 100. Now again, P was in kilopascal, so it's 100 kilopascal. Right now, the thing that you want to change is just put T1 here and P1 here, and boom, that's it. Right. In order to comment, you need to just double quote this, right? Now we have a basic program here, right? We by this program we are calculating the enthalpy of methane at temperature 40 and pressure 100 kilopascal, right? The process can be anything. It can be inside a turbine, it can be inside like a pump or anything, condenser, evaporator, anything, right? But it's like if you know the values of at least two variables, temperature, pressure, or maybe quality, anything, then you can actually calculate any other property, thermodynamic property, like enthalpy, entropy, anything like that, right? So we have the basic formula. We have commented this part because we don't really want the compiler to run this because it's going to show some errors here, right? So now the next thing that we want to do is just go and click on this calculate. You can actually check format first if you are not really sure about whether it's correct or not, right? Then it's going to show you that there are three equations and three variables. No syntax errors were detected. Compilation time 0.1 second, right? That's perfectly fine. If like you have some errors in there, then you can obviously just correct them, right? Now, if you want to solve them, which we really want to do, you can hit F2 on your keyboard, like it says F2, or you can just go to calculate and click on solve. That's it. So this is the window that pops up, the solution window, which says enthalpy is this much. Right. P1 is this, T1 is this, and all that. Now, if I want to check the unit of enthalpy, then what I can do, function info, right? There you go. So like the unit of enthalpy was kilojoule per kg, right? But now, as you can see, it's not really visible here. Neither is P1 and T1 visible here. So what should we do now, right? In that case, this variable info is quite handy, right? So you go to option, then variable info, then here you can find that units column is blank for every variable, right? So like in h, for h we'll say kg, kilojoule per kg. You can write it whatever you want. Software is having the unit specified, so it won't change anything. Like if I write T1 as Kelvin here, then it's not that the software is going to now calculate it in Kelvin, right? It's still going to calculate it in Celsius, but in that solution window, we'll see a K in front of the temperature, which is actually incorrect since temperature was already in Celsius, right? So we'll write C here and we'll write kilopascal here, right? We'll hit apply and then OK. And then if we click on solve, there you go, right? Everything is now looking good. Now, another way to solve this is just click on this calculator option button, which you can see that's going to do that again. It's the same, right? Now, suppose I don't want the temperature to be specific. I want the enthalpy of methane at temperature ranging from 40 200 degrees Celsius, right? So in that case, what should I actually do? Well, in that case, we'll just keep T1 as a variable. We won't really give it a value as such. We'll we'll click on tables, new parametric table, does not have an equal sign. Okay, well, why do I even need it? Oh, okay. So we don't really have to define the variable at all. All right, got it. Right. So without defining the variable, we'll just click on tables, parametric table, new parametric table. Now, number of runs or number of rows that you want to have in your table are defined here. You can obviously increase or decrease it, whatever you want, right? It's also really important because, like I said, if I want the the enthalpy from 40 degrees Celsius to 100 degrees Celsius at an interval of 10, then since the difference is 60, so I would really require what 40. Okay, let me calculate: 40, 50, 60, 70, 80, 90, 100, right? 7 rows I require, right? So we'll just enter 7 because we want the range to be like quite precise at 10 interval. Right now, what all variables do I have to import in here in the table? Now, since pressure is constant, so there's no need of pressure to be mentioned in the table. T1 is varying, so that it should be there. H again is a variable since it's affected by T1. So this is also going to be added in the table. Now we'll hit OK. Right. Now in this you can see that still the range is not quite there, right? But how do I get the range now? Well, there is an arrow with above T1. You can just click on it. First row, second, last row, enter values. The first value we want is what? It's 40. The last value we want is 100. Now in this option there are a number of options through which you want the increment to happen. Linear, increment, multiplier, log, it's all on you. I'll select linear since I want them at equal intervals of 10, right? I'll click apply, I'll hit OK, and there you go. We have 40, 50, 60 till 100. Right now, we want to calculate the value of h, right? We can actually just close it, and if we hit solve here, that's gonna show an error because there are two equations and just three variables, which really can't say, solve this equation, right? We don't have the value of t1 mentioned in this particular like this equation or everything, right? So we are not going to solve it from here. What we are going to do is tables, right? We won't really like what you say, select the, okay, where did the table go? Okay, okay. So yeah, so we are going to just open that parametric table that we created through Windows and then parametric tables. There you go. If you are having multiple tables and they are going to show you as tabs like in Excel, it happens table 1, table 2, table 3, right? So you can just click on it and then go on. Right. Now, if we want to solve the enthalpy for this range, we'll just hit this play button. That's it. There you go. All the values are there. And yeah, that's actually good. Now, suppose if I now require to just plot this table, right? Plot the H versus T chart for this particular example, right? So, what should I do then? Well, in that case, we'll just first close the table, go to plots, new plot window. Okay, new plot window, XY plot. Since it's like there are just two columns, so we don't really require a 3D plot, right? If there are three columns, then definitely you can go with XY plot, right? So I'll select XY plot, plot name, whatever, sorry, whatever you want. I'll say H versus T. There you go. Now, on the x-axis, what you want to define? We want to define T1. On the x-axis, y-axis, we want H, right? Parametric table, the thing that where it's going to pick up the values. So it's going to pick up the values from parametric table, whose name is table 1. Now, if you have 2, 3 tables, it's going to show up here. Table 1, 2, 3. You can select whatever you want, right? Quite simple. All right. Now, these are some like basic things. Yep. So we don't really have to look for them as such, and we can like literally just click on OK. Right. So this is the that we get. Now it's really kind of very simple one because the variation was linear, but in some case it's going to be curved like hell, right? So yeah, it's kind of a handy thing to have. Right, there you go. We closed it. I don't know how to open it. So yeah, don't do it. Okay. And this is how you zoom in, right? By just going and selecting, dragging, all that, right? This is going to create a number of windows over here. That's perfectly fine. So this is the basic introduction about what you can do, the potential of this software, right? And suppose if you are wondering why not make a 3D plot out of it, then let's go. Let's do it. Let's do T1H and what? Let's just keep this as okay. Let's keep it at T1 and click OK. 3D surface I want. Right. Okay. Yes. So this is what we get. Now, in order to move or like change it the way I'm doing it, you will have to use the middle mouse button, right? Press and drag the mouse, and you will be able to move it. It's not really that informative since the values that we wanted to use were only two, right? So, yes, that's kind of one thing. So, yep, that's it, I guess, for today's video. I hope you liked it and you found it informative. If you did, then you can just click on the subscribe button and you can like comment down your doubts maybe in the comment section. And yes, I read all the comments and they are like you should be assured that yes, you will get a response. Right, that's it. And yep, like, share, subscribe, guys. Thank you. Tada, bye bye. Have a good day.